If you're asked to compute something involving the relative rate of change, we have this definition that the relative rate of change is the rate of change divided by the original function. And so to compute that, we just need the derivative that goes here. Then we'll divide it by the original function, the 1 minus 2t plus 4t squared stuff. So the derivative, nice and easy using the power rule. It's negative 2 plus 8t, right? Oops. The 1 comes down and multiplies, then the power gets reduced by 1 to make it negative 2. The 2 comes down and multiplies, then it gets reduced by 1 to make it 8t. So there's our derivative. We'll find the relative rate of change by taking the derivative and dividing it by the original function. And we're asked to find this when the relative rate of change is r is equal to 2. So we want to put 2 for r. So to solve this equation, the problem is that you have the variable you want to solve for in the denominator. So you want to multiply both sides by 1 minus 2t plus 4t squared to make it cancel out in the bottom. So when you do that, you got 2 times the 1 minus 2t plus 4t squared in the on the left side of the equation, and that makes it cancel out on the right side when you multiply it to the right side. And then we can distribute that 2, make that 2 multiply to everything. And then we can combine like terms, get everything all on one side of the equation because we want to set this equal to 0. It's quadratic, right? Highest power is a squaring power. So you can add that 2 to both sides. So that way we get rid of the negative 2. So it makes 4. And then I can subtract this 8t from both sides to make negative 12t plus 8t squared, and that equals 0. So this is a quadratic that's factorable. I can factor out a 4 from everything, and I'll put it in descending powers here while I'm at it. I delete it. Shoot. Okay, so this is factorable. We can factor out a 4. And then this is a factorable trinomial. If you remember from previous math courses, what you'd want to do is multiply 2 times 1 to make 2. And your goal is to find two numbers that multiply to be 2 but add up to be negative 3. And so the only pair we can do is negative 2 and negative 1. So what you would do is you'd replace that middle term with minus 2t minus 1t. Hopefully that is a reminder about what to do with factoring. But then you would want to factor by grouping from there. Make a group here, make a group here, and then factor. So we can factor out a 2t from the first two terms, and we get t minus 1. And then over here, I'm going to factor out a negative 1 just to keep my leading term positive, and we get t minus 1. And then the last part is that both terms have a t minus 1. We can factor out t minus 1. And we're left with 2t minus 1 for the other parentheses. The alternative here is you don't have to factor if you don't want. You could just plug this into the quadratic formula to solve too. But the big point is that we get two things. We get, when you set each factor piece equal to 0, you get t equals 1 for one of the solutions, and you get t equals 1/2. So there's two solutions when r equals 2. We want to find out the one that minimizes it, that minimizes the smallest value of t, such as the relative rate of change. Oh, okay, so we want the smallest value of t, that would be t equals 1/2. That's the smaller of the two values.